So this lesson is optimization problems 3. So this is the grand finale. This is where we see where we're going with this stuff. So let's just get right to it. Live Nation, the company that organizes AC/DC concerts on their Black Ice tour, wants to figure out how much merchandise they should bring to their concert in Vancouver. A program occupies 5 cubic inches, and a hoodie occupies 50 cubic inches. A program costs Live Nation $5 to make. A hoodie costs $20 to make. So those are the creation costs of those 2 items. The company wants to spend no more than $51,000 per show on merchandise. There's a maximum space of 75,000 cubic inches for merchandise per concert. Actually meant to do it in, there we go, we'll do that so it matches up. The company expects a profit of $20 per program and $105 per hoodie. How many hoodies and programs should they sell to maximize profits? All right, so what are our variables?
Like the letters we're using?
Yes.
H for hoodie.
Sure. And what would the other one be? Let H represent the number of hoodies and let represent the number of programs. Just a curiosity, the last time I taught this, I was asked this, so I'm just asking. Do you know what a program is?
Like the
paper thing.
Yeah.
Like it tells you what's going, like,
Yeah,
not
like
what songs are playing in what order, but like
tells you about the band.
Yeah.
Tells you about the band, has lots of shiny.
pamphlet.
Yeah, or book. Yeah, it's a big shiny picture. It's completely overpriced, but everything else at a concert. Yeah, okay. So that's what it is, and it'll have usually other stops on the tour, like they're stopping in Winnipeg, Toronto, Moncton, wherever they're going. Okay, good. New Brunswick. Yeah, or Mr. Taylor's not from Moncton, but he's from New Brunswick. So okay. Now, from there, I highlighted in 3 different colors: black, red, and blue. Black. I guess it's more like a gray, but whatever. So the black and the red are 2 of our inequalities, and the blue is the objective function. So let's start with that. Let's also start with our inequalities in general. We'll say that we know that H is greater than or equal to 0, P is greater than or equal to 0. Because obviously you can't sell negative hoodies or negative programs. Then we're looking at our 2 quantities that are mentioned in this question. Those 2 quantities are what?
Cubic inches and dollars.
So like space
Yeah.
and
Money.
and cost. Yeah. Yeah, you could do it that way too. Space and cost. All right. So looking at space then, what's an inequality that we can use for space?
Just a reminder
So,
to all homeroom classes, you are headed out
going
now
to
to
be
the healing circle. All homeroom classes and teachers headed out to the healing
5P.
circle. Thank you.
Plus 50H is less than or equal to 75,000. So there's our inequality that has to do with space. What would our inequality be for cost?
P5 plus H20 has to be smaller than 51,000.
Yes. Perfect. Yep. Good. So those are our inequalities. And the objective function, I guess we should also probably think about that now. the objective function. I'll move it down a little bit. Leave some extra room there. The objective function. We're trying to make profit here, so profit is going to equal what?
20p plus 105h.
Good. Okay, there's our objective function. We won't have to deal with that though until we completely graph the system and see what our graph looks like.
Do you need to use different letters for the profit because it's the
Oh.
same?
Yeah,
Or does it not matter?
yeah, I mean, it kind of matters. Like, I guess we probably shouldn't use a P, but for some reason my program is not even really letting me erase. So, let's call this, I don't know. We call whatever we want. Let's just call it M. It doesn't matter what we call it, really. Really doesn't matter. But I mean, in general, if one's a capital P and a little p, it's still kind of confusing. So yeah, we'll just call it a capital M. M for money. There you go. Okay, there you go. All right. So now let's go ahead and make our graph. Again, before we start going into anything else, it would be probably best just to graph this to figure out where our points are. And then we can figure out what our scale should be. Okay? If there's 25 grid squares, I'm tempted just to make every grid square horizontally like 1,000. So we'll get up to like 25,000 horizontally. So this would represent the programs, and this would represent the hoodies. I'm tempted to go up to about 20. Everyone's 1,000. So 1, 2, 3, 4, 5.
X is P, right?
Yes. Okay. So we have the programs on the horizontal axis. And with the hoodies, we saw that it goes just over 25,000. So we can't really go just up 1,000 for each one. It's honestly, it's going to be kind of overkill, but I would just make everyone 2,000. And then we're going to go every 5 squares will be 10,000. So that would be 10,000. 20,000, 30,000, 40,000, and 50,000. And then it's just a matter of making our intercepts and putting them in. So we know we're going to have one at 25,500. And that same line is going to intersect the x-axis at 10,200. Okay. And if I take a look at what those other intercepts are going to be, there's one at 1,500. And at 15,000. Oops. The only thing is I want these to be different colors. Let's see if I can do that. Let's see if I can erase this. Guess I can. Yay. All right, I'm going to do it in blue then. That's 1,500. Any other intersection point is at 15,000.
Why is mine only crossing at 0 and 2,500.
This is a good lesson for us because now a lot of this is not necessary because it doesn't even go up to 10,000. So it means that we should alter the scale completely if we can. And for some reason it's not letting me, which is great. What do I want to do about this? I know what I want to do. I'm going to relabel the vertical axis. So the max that we're going to get to up here is 5,000. That's 1,000. 2,000. 3,000. 4,000. Okay. All right. Now that we got that, we can go ahead and graph these lines. So we'll graph this one first. And then we'll graph this one second. And it does work out perfectly with the intersection point. And that's the thing, if you graph this well, you will see that the intersection point is pretty obvious, and it is pretty obvious here at 7,800. And of course, what we're going to do with this is shade this part of the graph right here. And that's what we get. So there's our graph. Any questions with the graph?
Can you just stipple it because
We would stipple it. So I mean, it doesn't hurt to do that little thing where we do this and say that P and H are elements of whole numbers, which means that they can be positive. They have to be positive and they have to be whole numbers. No decimals or fractions allowed. Also won't hurt to label your inequalities either. So just while we're on that, it would be, the blue one is going to be the 5p plus 50h is less than 75,000. And the red one is going to be 5p plus 20h is less than or equal to 51,000. Okay, so what do we do? Well, what am I going to do here? I know what I'm going to do. I'm going to do this. So I'm taking a little screenshot here. So I'm taking this piece of the graph and putting it down here. So from this, there are a few points that we call corner points. So they are this point here, this point here, this point here, and this point here. They are the corner points for this quadrilateral type shape. So those points are 0, 1,500, 0, 0, 7,800, and 10,200, 0. Remembering that in these ordered pairs, P is the first number is the number of programs, the second number is the number of hoodies. So what we want to do is we want to evaluate the objective function with each of these points. So we'll start off with the first one. M is equal to 20p plus 105h. So that's 20 times 0 plus 105 times 1,500. So obviously we don't have to worry about 20 times 0. But if we take 105 times 1,500, we get 157,500. That means if the band takes 0 programs and 1,500 hoodies, they'll make $157,500 in profit for the concert. Okay? So that is the first point evaluated. The second point is pretty straightforward. If they don't bring any hoodies and they don't bring any programs, how much money are they going to make? 0. You don't have to do that one. 7,800. Let's see if that one is better than the first one. So it's going to be 20 times 7,000 plus 105 times 800. So 20 times 7,000 would be 140,000, if my math is okay. And then we have 105 times 800, and that's 84,000. So if you combine those together, you get $224,000, which is clearly more than the first one. So right now, the grand and glorious winner is 7,000 programs and 800 hoodies. But we haven't tried the last one yet, so we'll do the last one to see if it becomes the combination of programs and hoodies that maximizes revenue for Live Nation. So M is equal to 20P plus 105H. This is just going to be, what if they just took 10,200 programs and no hoodies? Well, then you're going to end up with 20,400, which is less than the other ones. This should be 204,000, not 20,400. That's what I did wrong. But it's still not as much as the last possibility. It's over 200,000, but it's still not the most. So obviously what we see is there is a grand and glorious winner here. The grand and glorious winner is 7,000 programs and 800 hoodies. So then we should make some kind of a therefore statement summarizing that. So let's go ahead and do that. Therefore, Live Nation should bring 7, we don't have to put it in order pair, 7, don't want it as a highlighter either, 7,000 programs and 800 hoodies to the Vancouver show. All right, next example. A doctor advises a patient to take vitamin supplements to provide at least 35 milligrams of vitamin C, but no more than 600 milligrams of calcium daily. So we're looking at like multivitamins here. Each brand A pill contains 100 milligrams of calcium and 5 milligrams of vitamin C. Each brand B pill contains 150 milligrams of calcium and 10 milligrams of vitamin C. Each brand A pill costs 4 cents and each brand B pill costs 9 cents. How many of each type of pill should the patient take daily to minimize the cost of taking vitamins? So, what are our variables in this question?
Vitamins, I mean like grams.
So, we want at least 35 milligrams of vitamin C. Each brand A pill contains 5 milligrams of vitamin C. Each brand B pill contains 10 milligrams of vitamin C. We want no more than 600 milligrams of calcium. Brand A pill again contains 100 milligrams of calcium. And brand B pill contains 150 milligrams of calcium. And then we have each brand A pill costs 4 cents and each brand B pill costs 9 cents. So, what are the unknowns in this question? the number of brand A pills and the number of brand B pills. So let's let A represent the number of brand A pills and B represent the number of brand B pills. Okay? So the quantities that we are trying to come up with have to do with what? What are the inequalities going to be based on? Amount of what?
Vitamins?
Yes, but what is it going to be? But pick something that's going to be
Vitamin
controlling.
C and vitamin calcium.
Vitamin C and calcium. That's right. All right, so let's look at the brand A pills, or rather the vitamin C first. The vitamin C, we want at least 35 milligrams. So we want the vitamin C to be greater than or equal to 35. And brand A pill contains 5 milligrams of vitamin C. So that's 5A plus 10B. For calcium, we want calcium to be no more than 600. And brand A contains 100 milligrams of calcium, so that's 100A. And the brand B pill contains 150 milligrams of calcium. So there's our two inequalities. And of course, we also know that A is greater than or equal to 0 and B is greater than or equal to 0. You can't have a negative number of pills. The objective function, we're trying to minimize cost. So I'm just going to write cost equals each brand A pill is 4 cents. So that's 4 cents times the number of brand A pills. And each brand B pill costs 9 cents. So that's 0.09 times B. So now we can go ahead and get after this and graph this and see what we have for a scale. From what I can see, none of these numbers are going to be over 10. So if we could go up to 10, that would be really good. It won't be super amazingly easy because of we have 25 grid squares, but we could make every 5 grid squares go up by 2. So 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 8, and 10. That's brand A pills and brand B pills. 2, 4, 6, 8, and 10. All right. Now it's just a matter of graphing this. So you could graph this. I would graph this in Desmos and just see where the intercepts are. Okay. I see the first intercept is at like 3.5. And actually, no, it would be, no, that's right. And then it would be 7. And then we can go ahead and graph that with a line. Okay. But that graph, that grid, we won't be shading below it. I will actually be shading above it.
Wait, how much is each grid square worth?
Each grid square, this isn't ideal. Each grid square is worth like 0.4. Because 0.4, 0.8, 1.2, 1.6, and 2. for the calcium, it's going to be, there's going to be at one at 4 and one at 6. And then you just connect the dots. So the real $1 million question we have here is where is the solution region? Where is the solution region? So for this question, the shaded area is right here. Where do these points intersect, or lines intersect rather? 3 and 2?
That's what Desmos said.
Okay, 3 and 2. So, where are our corner points? Just only going to be, this object is a triangle. So the corner points are here, here, and here. Those are your corner points. Okay? Those are your only corner points. So the corner points are 0 and 3.5, 0 and 4, and 3 and 2. Now, this is another time when we have this conversation, because this is funny. So when we did the chicken and turkey question, when I did it with Brianne, we agreed that you can only have a whole number of turkeys and a whole number of chickens. Remember that, Brianne? Earlier in this unit?
Was that when I was the only one? Oh.
Yeah. Yeah. I pre-taught you that lesson, and then I taught everybody that lesson, and everyone was like, well, no, you can have half a chicken and half a turkey. So we went with it. Like, it is fine. Like, we just got to state your assumptions. So I'm just going to ask you this. Can you have half a pill?
Yes, but you can't buy a pill.
No, but you can't buy half a pill. So how can you have half a pill?
Different doses.
Different doses are cutting it in half, right? Now, it would be different if it was like 0.7 of a pill, because then that becomes a little dicey. Like, how can you make sure to get 0.7 of a pill? And really, like, even when you cut a pill, like, unless it has, like, the little area that you can cut, it's really hard to get exactly half, right? But, okay, we're assuming we can have half a pill. Okay, cool. Half a pill is okay. So if half a pill is okay, let's use logic here, okay? If we're trying to minimize cost, which one of these two goes away right away?
3 and 2.
No, the two I'm circling.
0 and 4.
Right. Because 0 and 4 is going to be more money than 0 and 3.5. Right? We can acknowledge that. If you have 4 of something, it's going to cost more than 3.5 of something. So if we're trying to minimize cost, this one's already out the door. So the question is 0, 3.5 cost less than 3 and 2? Well, let's take a look. So cost is going to be 0.04 times 0 plus 0.09 times 3.5. So that's going to be 27. It's going to be 31.5 cents to take 3.5 pills a day. 31.5 cents. Okay. How about for 3 and 2? Well, 0.04 times 3 plus 0.09 times 2. And the cost is going to be 12 cents plus 18 cents, which is 30 cents. So the 3 and 2 wins. The 3 and 2 wins because this is lower. In this question, we're asked to minimize the cost. Minimize means make smallest. So we only minimize the cost if we pick the smallest number. And the smallest number is 30. So it's 3 and 2. So we'll put that into a therefore statement and say that the patient should take 3 brand A pills and 2 brand B pills to minimize the cost. Right, the last example is very straightforward because it's just, there's no word problem. There's no word problem. It just gives us this, and it asks us to, what we'll be trying to do. It doesn't tell us this, but I'm telling you. This is an example of where we're going to minimize. So we're going to try and minimize this optimization problem. And we're going to do that using the corner points. Now there's only 3 here. So there's only 3 corner points here. That makes sense.
What does optimal mean?
Optimal value means which XY pair will give us the smallest value for this.
Oh, so optimal
Now,
means small.
well, no. It's smallest. It's basically, it's which pair is going to make this the smallest or the biggest. Because sometimes we're trying to make this the smallest, and sometimes we're trying to make this the biggest. There's not enough clear instructions here. That's on me saying whether we're minimizing or maximizing. But if we use logic here, if we're trying to maximize, this would be easy because it would just go into infinity to maximize it, right? Right? Because if you get bigger and bigger and bigger and bigger, well, then this is going to get bigger and bigger and bigger and bigger. So if we're going to try and optimize this, the only way to do it would be to minimize it. So which one of these corner points is going to help us minimize this? Is it going to be this one? Is it going to be this one? Or is it going to be this one? So this one is 0 and 19. This one is 10 and 4. And this one is, this one is 15 and 0. So we have three order pairs.
We're doing this again, right?
0, 19, 10 and 4, and 15 and 0. And we want to try and minimize that objective function. Four x plus 3y and we won't know until we substitute all those order pairs in which order pair will minimize this the most. So if you work out each of those points, the point that I get that will be the optimal point would be what?
15 and 0.
Are we minimizing or maximizing?
Hold on, I think I did my math wrong.
Or maybe I did my math wrong. No, I think I'm okay.
Oh yeah.
Is it 10 and 4?
It is 10 and 4. Yep. Yep, it's 10 and 4. Because it gives the lowest value, 52. So we'll put a little therefore statement and just say that 10-4 will optimize the objective function.